These are the answers for fact file 2.1 Formula, percentage yield and atom economy. Question 1. 5 grams of butan 1-ol with a relative molecular mass of 74 reacted with an excess of hydrogen bromide and 6.4 grams of 1-bromobutane, relative molecular mass of 137, were obtained after purification. Calculate the percentage yield of 1-bromobutane. So we're first going to work out the moles of butan 1-ol. So the number of moles of that is the mass divided by the formula mass, so 5 divided by 74, which gives us 0.06757 moles. The moles of bromobutane would be the same, so because it's just a straightforward substitution reaction, so you're substituting the OH in the alcohol for bromine in the bromobutane. So we have 0.06757 moles of the bromobutane. So the theoretical yield is the 0.06757 times 137, which is its molecular mass, which gives us 9.26 grams. So then the percentage yield is the actual yield, which is 6.4, divided by the theoretical yield, which is 9.26 times 100, and that gives us 69.1%. And the marks there come from 1 mark for getting the number of moles, 1 mark for getting the theoretical yield, and 1 mark then for working out the percentage yield. Question 2. Analysis of a compound which contains carbon, hydrogen and bromine only showed that 22.2% of its mass is carbon and 3.7% is hydrogen. The relative molecular mass of the compound is 216. Calculate the molecular formula of the compound. So we want to work out the empirical formula first. I'm going to do that just by writing down the elements here: carbon, hydrogen and bromine, and then I'm putting the quantities from the question, so 22.2 for the carbon, 3.7 for hydrogen and 74.1 for bromine. We're going to divide by the relative atomic mass. So for carbon that is 12, for hydrogen that is 1, and for bromine it is 80. Divide through by those, that gives us 1.85 to 3.7 and 0.9263. Divide by the smallest, and that's going to give us 2 to 4 to 1 for our ratio. So our empirical formula would be C2H4Br. Okay, so that's the first step. The second step then is to work out the molecular formula. So we're told that the mass of the compound is 216. We work out the mass of the C2H4Br. So 2 12s plus 4 1s for the hydrogen plus our bromine, which is 80. And that gives us 108. If we then take the mass of the molecule, which is 216, not 218, divide by 108, that gives us 2. So we then know that we have 2 lots of the C2H4Br, which gives us C4H8Br2. And the marks here are assigned for 1 for the empirical formula and 1 for the molecular formula and 1 for getting all of the numbers of moles correct here in your working out. Right, number 3, calculate the volume of oxygen gas measured at 20 degrees and 1 atmosphere of pressure, which would be produced when a 500 sorry about that, when a 50 cubic centimetre sample of 2 moles per dm cubed hydrogen peroxide solution undergoes complete decomposition. So first of all, we want to work out the number of moles of the hydrogen peroxide, which is 50, times the concentration, which is 2, divided by 1,000, which gives us 0.1 moles. Then we work out the moles of oxygen. So we have 0.1 divided by 2, which is 0.05 moles. And then the volume of oxygen is 0.05 times 24000, which is 24 dm cubed, which is 1200 cubic centimetres. Or you could write that as 1.2 dm cubed. And finally, copper can be extracted by heating copper 2 oxide with carbon. Calculate the atom economy of the reaction. So the atom economy is the mass of the useful products divided by the total mass of the products. So we wanted to know how much copper can be made. So our mass of the useful products, the copper, is 128. The total products then, including the carbon dioxide, is 172. We multiply that by 100 and that gives us 74.4%. And the marking points there go for 1 for getting this part of the calculation right, and your